What is up, guys? Welcome to yet another episode of Math Made Easy. I am really sorry I could not get any math content out yesterday, but I hope that you enjoyed that video. And today I will be doing some more math, so let's get started. This is going to be about the apothem perimeter theorem for finding areas of regular polygons. Sorry guys, just got a quick call. So if you are a lame person, right, what you will do is you will split this regular hexagon. It's a regular hexagon, guys. Just what it is. Okay. So we'll divide it into triangles, find the area of the triangles, and then multiply that by 6, okay? But that's what lame people do, guys. And here at Math Made Easy, we are not lame people, okay? So we instead would use this formula. 1/2 apothem times perimeter is the official formula, but I like to think of it like this. Apothem times semi-perimeter. And no, this does not have another S on it. And really, when you think about it, and basically, when you think about it, this is actually kind of doing the same thing as the lame method, but the lame method is just a lot of times much more complicated and a lot more burdensome. So, if we think the perimeter is all of this, right? The apothem is this value. Okay? This length. So, if we kind of flatten this thing out, we get something that looks like 1. So we would get a long thing that has like a bunch of teeth almost. 3, 4, 5, 6. We would get something like this. And this is the perimeter, and this is the apothem, and of course 1/2 of this equals the whole area because it's triangles. But let's try to have this in action. So 1/2 apothem perimeter or apothem semi-perimeter. So a regular hexagon has apothem 3√3 inside length 6. What is its area? Okay. So I'm imagining my hexagon. You don't even have to draw this stuff out, okay? It's regular, so I'm going to try to make it as regular as possible. This is not a regular hexagon, just to let you guys know. So this is from its center to kind of the altitude of our imaginary little triangles. Yeah, you know, I was sitting in on a high school math class the other day, and a lot of those kids, they were struggling with this stuff. They were struggling, so it's very hard. So this is our apothem. These are called the radius, but we're not gonna worry about that. When you can think about what the apothem and the radius represent, this apothem value represents the radius of the inscribed circle, and this radius value represents, so the apothem is like the radius of like this circle that's like kind of inscribed in here, and the radius kind of represents the circle that circumscribes this polygon, if that makes any sense at all, which it probably doesn't, but that's okay. You're not going to need to know that. So, and then the side length value, so like this, is 6. 6 was its area. So, we're going to take, so 1/2 apothem times perimeter. So we have apothem. We just need to find perimeter here. So apothem is 3√3. Keep that in consideration. Perimeter, though, 6 times 6. 36. So we can do 36. Or if you're me, you would just take the semi-perimeter, which is 36 over 2. 18. Multiply that, and you would get 54 root 3. So that's our first problem. And that was pretty easy. You think that that's all that I have coming for you today? No, it's not. So, this problem is a monster, guys. A monster. Regular heptagon has side length 8. Okay. What do we see? We see a regular heptagon, a 7-gon, and the side length is 8. What is its area? Kirk, they didn't teach us about how to find it, only knowing the side length. We need to know the apothegm. We can't do that. No, you can do it, guys. But for this, we need the help of... For this, we have my TI-84 Plus CE. And it has a nice little special message for you guys. So it's backwards. If you haven't done it, do that. Also, sub to me, turn on notifications, and hit the like. Let's get into it. So, jeez, Mom seems like she can't go 2 seconds without talking to me. But anyways, that's fine. So, a regular heptagon has side length 8. What is its area? So we're going to drop some. So this is one of the little triangles that are in this polygon. And we're going to pretend like they're all congruent because they are supposed to be. I'm just bad at drawing. So, what we're actually going to do is we're going to use tangent to find this. How will we use tangent? So this is our little thing. This angle right here is 360 over 7. And we know these are congruent because this triangle is isosceles because all radii are congruent. I should probably do this, and we know that this is 8. And we're trying to find this triangle's altitude. So we know half of this is going to be 4, because of course isosceles triangle, this altitude will bisect this segment, leave a right angle. And this is going to be half, so 360 over 14. So I'm going to go into my calculator. So we get 360 over 14. We get 25.7142. Okay, so I'll just kind of so this is approximately what the value of this little angle kind of on the top of our triangle that looks like this. Oh. Dang it. Mouse is annoying me. What just happened? Hold on, that's weird. Really weird thing, I had to draw this thing all over. Don't know why the computer crashed like that, but so here we go. So we know this top angle is equal to 25.714 approximately. So that means that this value, a, which we're trying to find, is just going to be the tangent of 25.714, because tangent is opposite over adjacent, but it's going to be cotangent, right? Because it's not tangent, it's inverse tangent. So adjacent over opposite. So the ratio, the cotangent of this is going to be the times our little length of this thing, which we know from earlier is 4. Gonna do that so we can go onto the calculator real quick. You just gotta do 1 over tangent on these things. So we get about 2.07, multiply that by 4, the side length, and we get something that looks like 8.306. So roughly this is our apothem, and then we take that and we will multiply that by our semi-perimeter, which we had declared was 28, right? Because if the side length is 8, 8 times 7 is 56, half of that is 28. So we have this times 28 is going to give us our area, which is, drumroll please, about 232.5704. Okay, let's move on to our last thing. So, oh my god, this one, apparently this question got deleted when my thing kind of crashed there, but a nonagon has perimeter 67.5, what is its area, so. So a nonagon, doing my best here, guys. Guys, tell me on a scale of 1 to 10 how bad is this nonagon in the comments below. We're going to draw in our little triangle here. So 67.5. 67.5 over 9. Well, 63 over 9 is 7. And then 4.5 over 9 is 0.5. So we have 7.5 is this. Okay, some quick maths. Dips. 7.5 is our side length. And our central angle is 360 over 9. So we have this here. It's going to be 40. Is our central angle, 40 degrees. Okay, so this one is going a little bit long this episode, but that's okay. So we have 7.5 means that when we triangle over here, drop this is going to be 3.75. And we're trying to find this. Okay, so let's look at this. Now this is 20, because it's 40 over 2. And we know this is 3.75, right? This thing, A. Or actually, probably call that something different. Maybe Z. When you can't call it A, call it Z just to be safe, guys. So we're going to take tangent of 20 over, sorry guys, cotangent of 20. 1 over tangent of 20. fact, I'm going to do the thing on here. So 1 over tan 20. degrees is going to be this 2.747. So make sure it's not in radians, make sure it's in degrees. Unless, of course, the problem is presented in radians, then, you know, radian all you like. And then we would multiply this by 360 over 9, so multiply this by 7.5 over 2, so 3.75. I am getting bad at this. We get this. Is there a both them? So this times our semi-perimeter, which we would find if its perimeter is this semi-perimeter would just be that over 2, which with some quick maths practice you can find is 33.75. And this times 33.75 is going to equal, drum roll, this is our answer. Guys, hope you enjoyed. Hopefully gonna get another geometry related kind of polygon video out today. And tell me if you want more on trigonometric functions. That's an advanced topic. I kind of wanted to cover it today though, because a lot of these questions do involve things like the tangent function. So I really hope you enjoyed, guys. That was pretty sick. Sorry, the video went a little bit long, but who cares? Have a good day, guys. This is Math Made Easy, logging off.